failure as far as an internal point of failure and make it an external point of failure. So what we're going to propose, let's go back up and kind of start with this modified drawing here. So again, all this main components, the frame, the block, the battery, the fuel tank, those all exist here, and we've got the fuel gauge and the temperature gauge. So what we're going to do is eliminate this power supply, this 12 volt power supply coming into point I. We're going to run it to an external regulator, which is going to step it down to 5 volts. This is like a $10 part off of Amazon. Obviously, you don't need to do this, but you're left with this point of internal failure. So we're going to make sure we have 5 volts, at least for demonstration purposes, to both gauges. So we're going to get 5 volts to point A. The jumper wire will send that over to the temperature gauge, and that's how we're going to test it out. So that is something I plan on having installed whenever I get done with all of this. So what does that look like inside this schematic? So again, I've tried to correct some of the things that I don't necessarily either understand or agree with. So the schematic here on the right, we have a 12 volt power supply coming in. This would be the correct way of drawing that, if I'm correct in my understanding. That would put R1 in series and provide 5 volts here. That's assuming that we kept this intact. What I'm going to do is actually bypass that voltage regulator, R1, provide 12 to 15 volts to this external regulator, and just have it connected to point A on the temperature gauge, and the jumper wire will provide that over to the temperature, the fuel point. We're going to provide 5 volts to the fuel gauge, and the jumper over to the temperature gauge will provide 5 volts here as well. So again, I've kind of corrected the flip-flop resistance that were labeled in John's diagram. So this is kind of what we're going to do.